What we are going to look at today, we're going to do a little bit with inequalities, and then we're also going to transition and do a little bit with exponents. Both topics should be review of things that you did in Algebra 2, but especially the inequalities. Sometimes in pre-calculus, we have different notation for things than maybe what you've seen before. The concepts are still the same, just the notation is slightly different. So for this first one, what we're going to look at is we need to multiply each side by -8. And when we multiply the right-hand side by -8, we would get -8x plus 8. And then the left-hand side, all we did there was cancel out that -8. Now, to save us a little bit of time and writing, I'm also going to go ahead and distribute that 3 to get 6x plus 48. Now, notice, because we did multiply by a negative number, that means that this inequality in the middle will have to switch. So from here, what we're going to look at is we're going to go ahead and move our x's to one side. So we get 14x, and I'm actually going to go ahead and subtract the 48 at this step, just to, again, save us a little bit of time and energy. And we would get, again, we haven't done anything with that inequality because at this step we did not multiply or divide by a negative. And so you get negative 14x is less than or equal, excuse me, 14x is less than or equal to -40. Now notice we do have to then go ahead and divide, and we're going to get in the habit of leaving things in fraction form or improper fractions. It does say that in the directions. So we're going to go ahead and divide by 14. And so at this point, we have x is less than or equal to, and when we simplify that -40 over 14, we would get -20 over 7. Notice it does say to solve and to graph. Now, you guys are used to writing your answers in that notation, and then you're used to graphing this. Notice it does have a less than or equal to sign, so you guys are used to having a closed circle when it's equal to, and since it's less than, it's going to go this direction. However, your book notates things slightly differently. So instead of writing your answers as an inequality, they will write it in what's called interval notation. And what interval notation means is that if you look to the left here, it's going to go all the way to negative infinity. And then as you look to the right, it's going to stop at -27. Now, the key that you have to remember in terms of your interval notation is whether or not you have a parenthesis or you have a bracket. The bracket indicates that it's equal to. So for example, at this -20 over 7, it is a bracket. However, infinity is something we can't ever get to. So whether it's positive infinity or negative infinity, that side is going to be a parenthesis. So again, that's interval notation. In terms of the graph, sometimes our graphs look a little bit differently as well. Instead of an open circle or a closed circle, it's going to have that parenthesis or bracket kind of in that graph. So what I mean by that is you would have -20 over 7. That's where that point would be. And since it is included, it's going to have a bracket there pointing to the left. So I just wanted to point that out to you. The interval notation is the big one. The graph part is something that you will see in answer keys, and I want to make sure you're familiar with it. So when you look at the next one, okay, notice that you have a compound inequality here. You do have the or in the middle. You're going to go ahead and distribute just like you have before. So you get 4 minus 6c less than or equal to -2. We can go ahead and finish solving this. So we're going to subtract 4 from each side. And then again, we're going to be dividing by a negative here. So we have to flip that inequality. On the right-hand side, we would have 4c, and then we're going to have less than -8, and so c is less than -2. Again, that or comes down with it. So that would be your inequalities that you're used to seeing. But again, what we're going to look at is what that interval notation looks like. And sometimes when we graph it, it sometimes is easier to see. So when you guys are used to graphing this, your -2 will be on the left-hand side. Your 1 will be here. An open circle at -2, since it's less than, it's going to the left. Closed circle at 1 going to the right. And then again, if you were doing the graphs the way that you might see it in your book now, it's the same concept, but again, at that 1, since it's including, it's going to be a bracket. Since it is a -2, it's going to be a parenthesis since it's not including. So parentheses versus and brackets versus open circle and closed circle. In terms of interval notation, if we're looking at this half of your graph, it goes from -infinity to negative 2. It doesn't reach negative infinity, so that's a parenthesis. Negative 2 is not included, it's a parenthesis. And then the right-hand side of your graph will be 1 to positive infinity. Again, infinity can't be reached, but 1 is included, so it's going to be a bracket. The only other thing to make note of with that is since it is an OR situation, you're going to have the symbol for OR, which is just a U in the middle. Okay, so take a minute, pause the video, go ahead and try out the last one, and then we'll throw the answer up here for you guys. Again, get used to both the interval notation and the original notation, kind of make sure you know how those kind of go back and forth. Okay, so after you paused it, you will have a is greater than or equal to -9. You will also have a is less than -4. That is the notation you guys are used to seeing. In terms of interval notation, what that would look like is it goes from -9 to to -4. The -9 is included, 4 is not. And again, when you were to graph this, it would be -9 and -4. If you're using close and open circles, close at 9, open at -4. If you're using the brackets, it would be a closed at -9 and a parenthesis there with everything in between. Okay, so again, the big key that is new is this interval notation. Get used to it. You're going to see it a ton in this class. All right, moving on to oh, we already did that, so forget that. Moving on to exponents to make sure that you guys are familiar with those. So reminder, those are the properties that you guys have seen prior. So we're just going to simplify these. Okay, notice anything with the same base, you can go ahead and combine. So we have 5 to the 5th on the top times 3. You leave the base alone and you use your exponents to combine those. So you have your 3 and your 4 for the exponents. Since we are multiplying, those exponents are going to be added. And then we have 5 to the 10th times 3 squared. Now, when you guys look at this, I want you guys to think about this logically. For example, the 3s, the 3 to the 7th is 3, 3. So you have 7 of these. So that's 4, 5, 6, 7. And then on the bottom, you have 2. So when you think about this, it makes sense that as you cancel top to bottom, you're going to have 5 of these left. So that's why when you look at this 3 and this, or sorry, the 7 and the 2, you end up subtracting. So you end up with 3 to the 5th on top. And then the same thing here, you're going to end up subtracting that 5 and the 10. The difference is you have 10 on the bottom. So that's where the leftovers, that 5 to the 5th, is going to go on the bottom. Okay, so again, when you multiply, you add your exponents. When you divide, you subtract them. Now, the next one is a little bit more complicated. So when you guys look at this, just make sure, take your time. There's several different ways that you could take your steps. So for example, even that first one, I technically could write that as 3 over 5 to the 5th power because that's the exact same thing as this. It's just written in a different way. So there are different ways that you could take steps. So for me, what makes sense to me is to go ahead and take this -3 to everything. Now remember, when you have a power to a power, you're multiplying. So this becomes 3 to the -3rd. X, you're going to do a -1 times a -3 to get to the +3. And then y is to the -9th power. When you look down below, you just go ahead and copy that straight across. And then for me, what makes the most sense in my brain is to go ahead and move those negative exponents. So if you forget what that looks like, anytime you have a negative exponent, whatever is attached to, you move it. So if it's originally on the top, like this one is, you move it to the bottom. So that 3 to the 3rd goes on the bottom. X to the 3rd, which comes next, is positive, so it stays put. And then y to the -9th, you change the exponent to a positive, and it moves to the bottom. And then we look at the bottom ones. That 9 is going to stay put. X to the squared, or excuse me, x to the 2nd, or x squared, stays put. And that y to the -6, it's going to move, but that exponent then changes to be a +6. Okay, so then when you look at this, you can go ahead and do this 3 to the 3rd if you want, but the parts that I'm going to focus on right now are my exponents. So if I look here and I look here, that's going to simplify to be an x on top. If I look at my y's, I have y to the 6th, y to the 9th below. So I'm going to subtract. That's going to become y to the 3rd. And then I'm going to go ahead and focus on doing the numeric part. So 3 to the 3rd is 27, 9. So 27 times 9 gives us 243. Okay, so I don't know why my pen is changing colors in the middle of this, but it is what it is. So I'm just going to rewrite it a little bit prettier just because I'm a little OCD. So that is just kind of a quick crash course on the properties of exponents.